Hi everyone, in this video we're going to go over another Leetcode question, word search. Major tech companies like Google, Facebook, Amazon, Microsoft are asking this question while they're conducting their technical interviews. I hope you will find this video tutorial helpful for your technical interview preparation. Let's start with reading the question. Given a 2D board and a word, find if the word exists in the grid. Excuse me. The word can be constructed from letters of sequentially adjacent cell, where adjacent cells are those horizontally or vertically neighboring. The same letter cell may not be used more than once. Example, we are given a board and we are constructing a word from the given letters, so these letters, and we can only look for horizontal or vertical neighboring. So we cannot construct the word using diagonals. We cannot use diagonals. It's typical like word search game, but we cannot use diagonals here. So for example, given word is ABCCED, ABCCED, there's one word here. And so we return true. Another one is C. C is here. So we return true for this one. A, B, C, B is missing, so we return false for this one. And there are a couple of constraints here. Board and word consists of only lowercase, uppercase English letters, and board and linked, and word and linked, etc. So this is a DFS problem. We will use depth first search recursively and try to find the given word in the board. Let's get on the whiteboard and try to solve this question. When the given word is, for example, home, it's here. What we are going to do is we will start searching in the grid using I and J indices. When we find the first character of the word we are looking for in this case H, we will stop. And we will call our DFS recursive function with backtracking. So what we will do is we will call the DFS function, and we will send a couple of parameters to this DFS function. And in the DFS, what DFS does is, let's put it a different color, it will check right if it's the words character is in the word, and check right again. Check right again. When it finds, it will return the word. For example, here it will check top, check the word, and this is not what it is looking for. It will backtrack, then check left, then go back and check down, and finally it will check right, and when it finds, it will return the word. So that's the idea. For example, in this one, where we can, for example, if there are only two letters, it will go up to two letters, then meet the last letter is not matching, so it will return from there. That's the DFS call. So it will just go do the depth first search, we'll deep search, then come back. Let's see the couple of boundary checks here. So we will pass the index number to the depth first search call. If the index number is equal to the word that linked, the link we're looking for, then we will return true. This index will count how many characters we've been through so far. We are searching If we don't meet the character, we will return anyway. If we come to this point, until this point it's the same as the word linked, then that means we found the word, so we return true. We count the number of words, number of characters with this index. Then second check is, I break down this call so you will understand better. Are we within the boundaries? Is this DFS call within this grid? And are we meeting the index character? So we met the H first, we went up T and come back, because after T at T we don't meet what we are looking for, so we return. So what we do is we check if board of I and J is the word character at index. Are we meeting the character? Is this the character we're looking for? If not, we return. We return false. If that's not, so for example, T is not what we're looking for, we return false. Or, yes. And we also mark the cells we go through as visited. So for example, we go through this home, we come across this O, then we set this one as visited. So we don't go through the same cells again if we are doing another search here, etc. So in this search, we set it to true. So if it's visited before, we are not visiting again. So we return false. So we are not visiting the same cells again and again. We set the visited to true. Now we are in the DFS call. We pass the recursion break. These two conditions break the recursion. So we pass them. Now we can set the cell that we are visiting to true, so we don't want to visit again. Now it's time for the recursive DFS call. So check up and down, check right and left, I minus 1 up, I plus 1 down, then J minus 1 left, J plus 1. And every time we increment index counter once. That way we will, at some point, we meet the word that linked. For example, I search up, if it's the character I'm looking for, it will search one step more. For example, this was H, oh, sorry, but then E comes, then it backtracks, go back. So, excuse me. So this is like it will go word I plus 1, J minus 1, J plus 1. So searches all the neighbors diagonally, vertically or horizontally. We are not using diagonals. That's the idea. If all of these searches check, if one of them, returns true, then we return true here. Then finally, if this is not what we're looking for, we couldn't find what we're looking for, then we set our cell to false, back to false for the next iteration, because there will be more iterations, more calls, and we return false. That's why we return false. So this is the DFS call. These are the boundary checks. So this is the boundary check, for example, I is greater than linked, I is less than 0, J is greater than board of I that linked, J is less than 0. This is the boundary check. Are we at the character index? Are we meeting the character? That's another check. And have we visited this node before? 3 checks here. We need to pay attention to 3 checks here. And 1 check here. Index is word that linked, then true. Search board, return, and false. Let's see this in the code. This is the given function. The question gives us this function. we created the visited separate Boolean Boolean array here. This way we set visited cells as true or false. So we keep it in separate Boolean array. So this is our board and string. We create the visited list. Then we go through the board I and j. When we meet, the character at 0 is equal to the cell I and j. If we find the first letter in the cell, and our search recursive DFS call returns true, then we return true. So we find the first letter, then we send it to DFS to search the neighbors. If both of them returns true, then we return true. Otherwise, we return false. This is DFS call. Check the word linked. This is the index tracker. So each time we send index plus one when we are doing the neighbor search. So we increment the index number this way. If board of I and j is not equal to word at index, character at index, so character is different, then we return. This is where we break the loop. So we go to the next call. And also we check the visited if we visited this one before. We don't want to visit the same cells over and over again. So that's another check. And are we within the boundaries? Here's the boundary check. Boundaries of the grid. And if we don't meet any of them, if we don't meet one of them, sorry, we return false. True, and set it to false, set visited back to normal. Then finally return false if we couldn't get what we want in this DFS goal, then we return false. Let's submit. This one works. So this is pretty much it for this question, and I hope it was helpful. I tried to break down the code into smaller pieces so you would understand, and I have more videos coming up, so if you subscribe to my channel, we can meet again in the near future. Thank you for watching. Goodbye.